Considering electric field and electric potential. An electric field is a region around a charged object where another charge experiences a force. Now, what is a field? Generally, a field is a region under the influence of some physical agencies. It could be gravitation, could be electricity, could be magnetism. We'll hear people talk about electric field, magnetic field, gravitational field. Let's look at a concept that we're most familiar with. If you have a magnet and a magnetic material, if you try to bring them close, you experience an attractive force. That magnet will attract that metal towards it, but you don't usually see that force. That is what we call the magnetic force. And the region around where that force is being experienced is called the magnetic field. You can notice that when you put it so apart, you may not experience that attraction. The force of attraction or that attractive force will only be experienced within the region of the magnetic field. So, mathematically, we can define electric field E as the force a unit charge, which we can say that E is equal to F all over Q. Electric field is a force per unit charge. If this is equation 1, recall that the electric force, which is also called the Coulomb's force, is defined as this. So if you want to define this, we'll now substitute equation 2 into equation 1, and the electric field becomes 1 all over 4 pi E naught times Q1, Q2 all over R square divide. This is the force we're talking about. The force divided by Q all over 1. But remember, we can express this as E equal to 1 all over 4 pi E naught times Q1, Q2 all over R squared times 1 all over Q. We are familiar with this. We are assuming these charges of equal magnitude. Assuming the charges are of equal magnitude, we have QQ all over this. So we can now cancel this. And finally, we have the electric field as 1 all over 4 pi E naught times Q all over R squared. This is the formula to calculate the electric field. Remember, this is a constant. It has a value 1 all over 4 pi E naught has a value of 9 times 10 raised to the power 9. And we're aware of that. So what is electric potential? Electric potential is the potential energy per unit charge in an electric field. And mathematically, we can define the electric potential V as 1 all over 4 pi E naught times Q all over R. Please do not mix up this. This is potential, this is electric field, and the force is what we have been using as Q1, Q2 all over R squared. So this 3, this is the electric field, this is the electric potential, this is the electric force. So if you are asked to calculate any of this, do not get confused. So we have a problem here to solve. A point charge of 6 microfarad is placed in a space. 1. Find the electric field at a point 0.2 meters away. B. The electric potential at the same point. Like I always tell you, you need to list out the parameters. Here the charge is given as 6 microcoulomb. But remember, microcoulomb is not the SI unit, and we need to convert from microcoulomb to coulomb. But for you to do that, you must know the relationship. And 1 coulomb is equivalent to 10 raised to power minus 6 microcoulomb. And since this is a smaller unit, you multiply. You are converting from a small to a big unit, to multiply. From a big to small, you divide. So from here, we are converting from a small to a big unit, so we are multiplying. So this will be equal to 6 times 10 raised to power minus 6 coulomb. Remember, our R is given the distance as 0.2 meters, and that meters is already in standard SI unit, so we don't need to bother ourselves. And then the constant 1 all over 4 pi E naught is given as 9 times 10 raised to power 9. So we now substitute. That becomes E to be equal to 1 all over 4 pi E naught times Q all over R squared. So what do? E now will be equal to 9 times 10 raised to power 9 times 6 times 10 raised to power minus 6 divided by 0.2 squared. So many students, when they see this, they get confused. Start looking for calculator. You don't need to bother yourself. We can do without calculator. E is equal to, this is the same base, so we normally add the powers. 9 times 6 is 54 times 10 raised to power 9 plus minus 6 divided by, if we square this 0.2, we have 0.04. So we can write this as E equal to 54 times 10 raised to power plus minus is minus. So this will become what? 9 minus 6 is 3. All over, if you convert this to standard form, this is 1, 2. So it will be 4 times 10 raised to power minus 2. So it's becoming easier for us, which we can say that E is equal to 54 divided by 4. Remember, if you take this up, become plus. So that will be times 10 raised to power 3 plus 2. So we now say that E is equal to, remember, 4 into 5 is 1. it will remain 1. 4 into 14 is 3. It will remain 2. So that will be points. If you add 0 to that 2, that is 20. 4 into 20 is 5. That is 13.5 times 10 raised to power 5. But we can write this as, if you like, 1.35 times 10 raised to power 6. And what is the unit? Electric field force per unit charge. That will be newtons per coulomb. And the second question is, we're calculating the electric potential. What is the formula for the electric potential? V is given as 1 over 4 pi E naught times Q all over R. Where we know the value of Q, we know this, we know this. So we simply substitute, and V will be equal to 9 times 10 raised to power 9 times 6 times 10 raised to power, that's the value of the charge, minus 6, divided by 0.2. So the same way we can do without the calculator, V now will be equal to, this time this is still 54 times 10 raised to power, if you add the powers, we now have 3 divided by 0.2. So we can still convert this to standard form by saying that 54 times 10 raised to power 3 divided by 2 times 10 raised to power. Remember, this is, we are moving 1 to the left, minus 1. And we can write this as 54 times 10 raised to power 3. If you take this to the last to the up, become plus 1. And we have 54. Remember, this is still divided by 2. So we can say that V is equal to, if you now 2 into 54 will give us 27. Is that right? 27 times 10 raised to power 4, which you can write as 2.7 times 10 raised to power 5. Is that right? 2.7 times 10 raised to power 5. So what would be the unit? What will be the unit? I hope this is not confusing and it will not confuse you. 27 times 10 raised to power 4 is the same as 2.7 times 10 raised to power 5. And the potential is in volts. Please, if you are confused, let me know in the comment section.